So we're going to start again with the application inspection capabilities of the zone-based policy firewall. So this allows the IS router to perform advanced inspections at the OC layers 5 to 7 in order to provide a higher level of security for your company or enterprise. And as I stated, this is a bit more than just saying Mesh Protocol FTP, which Mesh Protocol FTP or Mesh Protocol TFTP, it just allows the router to just understand the protocol, but doesn't do any checks at the protocol layer. It just listens passively as that traffic flows to the router back and forth to see if it's something meaningful, like, hey, the router, we're running an active FTP connection, make sure you allow the return traffic back in. But the router doesn't do any kind of security specific checks for the layer 7 with the Mesh Protocol FTP. So for that reason, we need to perform application inspection. And as I stated, it's going to affect router performance, which pretty much what it means is that we're going to in general use other dedicated solutions to perform what the application inspection capabilities of the router can do. So a couple of benefits is that one of them is that you're going to be able to restrict which applications can be used by the users to send traffic out on the internet. Like disallow, for example, I gave one example to disallow native messenger traffic. Because, for example, in a regular, let's say, production network, where there's nothing special, you don't have this. It's not a big enterprise. It's a regular, small, maybe medium enterprise. What you're going to be having, if you deploy on router 1 zone-based policy firewall, then pretty much going LAN to the internet, this direction, you're pretty much going to inspect like ICMP traffic to make sure that pinging works, TCP traffic, and UDP traffic. Because you got to make sure that users traffic is working out on the internet. Which what this means is that if this PC has, I give that example, but has one kind of application, like a messenger application, whatever that type of messenger is, Yahoo Messenger, ICQ, AOL, doesn't matter. That application is gonna run natively over TCP or UDP. Depends on the type of messenger application. You may not want to allow that messenger traffic out on the internet, but because you are allowing TCP and UDP and you're inspecting, it means that by default that traffic is gonna work, because you're allowing and respecting TCP and UDP. So application layer inspection is going to allow you to control, okay, I'm allowing TCP and UDP traffic out on the internet, but I want to look at the application layer to see if that's messenger traffic, just to drop it. Or other kind of support applications, of course, but a firewall which you don't want the users to use those applications to send traffic out on the internet. Prevents application tunneling. So you can do likewise application layer inspection to make sure that users are not trying to tunnel some kind of applications, like for example tunneling messenger over HTTP. Of course, nowadays the most dangerous tunneling method is going to be tunneling whatever you want over HTTPS, which is going to be secure. But still, for example, so you had that firewall policy in place in there, which you're inspecting TCP, UDP, and ICMP, but you're doing application inspection as well on that router to drop, for example, native messenger traffic. Native messenger traffic, it means that the user actually uses a messenger client to chat with its friends, for example. But of course, nowadays pretty much everything can be tunneled over HTTP, including, for example, Messenger, and that's from a long time ago. So if the user sees that its Messenger client doesn't work because of your policy, it means that what the user can do is it can fire up a regular web session, web traffic, a regular HTTP session, and over the HTTP session to tunnel is going to tunnel over that HTTP session messenger traffic. So it doesn't use the client, the messenger client anymore. The messenger traffic is not native. It's going to tunnel that traffic by using a browser and sending that traffic through a browser, so over a HTTP session. So for that reason, you may want to inspect HTTP as well to make sure that nobody tunnels anything over HTTP. They're actually using regular HTTP traffic out on the internet. They're not tunneling some kind of applications over HTTP. Of course, nowadays this is pretty much useless, because nowadays if somebody wants to tunnel something out on the internet, it's going to make use of an HTTPS session, of an SSH session, whatever it's encrypted, SSL VPN, IPsec VPN, because this router cannot inspect that traffic because it's encrypted. So clearly nowadays you actually need other resources, other kind of tools in the network to make sure that users cannot tunnel traffic over an encrypted channel. Also, it provides a basic level of security at the application layer. Like for example, you can inspect SMTP to restrict the number of recipients within an SMTP conversation, because it's well known that very simple, let's say marketing email or phishing email or whatever is going to have, or spam email is going to have a lot of recipients. So you may configure zone-based policy firewall so that as traffic comes from the internet, you may have in here, let's say on router 1 in a DMZ security, in the DMZ zone, you may have your SMTP gateway. So you may configure the zone-based policy firewall so that traffic is being received from the internet, and it's SMTP is going to look at the application layer, and for example, if it has more than, I don't know, 10 recipients, then drop the email. So it provides a very basic, let's say, security level for a lot of applications. Or for example, it can perform also URL filtering. Of course, nowadays you're going to use the dedicated proxy for that, but it can do that as well. It can look at the application layer at the HTTP header and restrict traffic going to specific URLs, or to restrict some downloading via HTTP. So a lot of things are supported in there. It can also prevent malicious application layer traffic. Like for example, I said this here, and here you can restrict SMTP or FTP commands, or can restrict HTTP methods. Like for example, let's assume that likewise you have again that DMZ zone in here, the DMZ zone, where we have some public services. Like you have an SMTP gateway, and you have a web server, for example, and you find out that there's a new vulnerability showed up in the internet, which makes use of a specific HTTP method, for example, which means there's a specific way to ask for HTTP traffic, a method, which the systems are vulnerable to that method and may cause an exception on the system, on the HTTP server, which the attacker can make use of that to take control of the system because of buffer overflow or any kind of exceptions which happen on the system. So as traffic comes from the internet and goes to your web server, you may configure the zone-based policy firewall to drop all incoming HTTP requests that are using that specific HTTP method. Or if that's an FTP or SMTP server, the same way. So you can take control over how can a protocol behave in there. What are the allowed options for each protocol which is supported for inspection? And of course, it also does protocol conformance, so it makes sure that if you do HTTP inspection, or if you do SMTP inspection, you can configure the zone-based policy firewall to make sure that that communication is like per the standard. There's nothing suspicious. Somebody tries to send some malicious HTTP or SMTP packet to target the SMTP server or web server to have an unexpected behavior because it receives a malformed HTTP packet at the application layer. Now, supported applications for inspection may depend, of course, on the code. Actually, it does depend on the code and platform, but most commonly it supports HTTP inspection, pretty much all the email protocols, SMTP, extended SMTP, POP3, IMAP. Since we're here, for example, a very simple question: who knows what's the difference between SMTP and extended SMTP? So as a security engineer, one of the things that you gotta be aware of is that you gotta know how protocols work, like inside out. Because how can you secure a network with a couple of protocols if you don't know how those protocols run? Just filtering something back and forth is not gonna be good enough. Then, of course, peer-to-peer traffic, which it's like torrents, instant messaging traffic, AOL, MSN, Yahoo, ICQ, Sun RPC, SIP, H323. So it supports a couple of, let's say, application inspect. It supports some couple of protocols, application layer to be inspected. So the difference between SMTP and ESMTP, it's in the name. ESMTP, it's extended SMTP, which adds additional capabilities to the SMTP. One of them is that SMTP allows you to send attachments. So initially, mail via SMTP was just text, no attachments, for example. Now, application inspection configuration-wise is going to be very simple. So first of all, you optionally can configure a parameter map of type regex. Now, depending on the application inspection type you want to perform, you may need a parameter type of type regex or not. It depends. But of course, what that parameter map does, it allows you to granularly match on some portions of the application header, because we know what a regex means. We're going to see in a couple as well. So depending on the type of the application of inspection, or what do you want to perform, which inspections do you want to perform for specific applications, you may need or you may not need to configure a parameter map of type regex. Then what you do, you configure the application inspection, which is going to be a layer 7 class map, where in there you match on the traffic, like match on the layer 7 on the traffic application header. Like if you want to do HTTP inspection, you're going to configure, or FTP inspection, you're going to configure a class map of type FTP and match on something in the application header, something which is FTP specific, like for example a command which is allowed the FTP layer. So in there you're going to configure what do you match within the application header. And then you configure a application inspection policy map, like a layer 7 policy map of the same type for the same protocol, and then you define the firewall policy. So you're gonna bind in the policy map of type of layer 7, the class map of layer 7, and define the firewall policy. Okay, so now that I match on the application header with the class map, what do I want to do if I match with traffic on that? If I see traffic matching on my rule, what do I want to do? What is the firewall policy? And the options are allow, log, or reset. As you're going to see in a couple, you cannot do deep packet inspection without performing regular firewall inspections. And I hope that makes sense. So as you can see in here, I just tell the router what to do, what is the action to take if something matches my layer 7 application, let's say, policy. But with this kind of configuration, I don't tell the router if it should pass the traffic, drop the traffic, or inspect the traffic. So for that reason, then we enforce the application firewall policy by applying the application inspection policy map. And that application inspection policy map, it is being applied at the layer 3 or 4 class map level under the layer 3 or 4 policy map. It's going to make sense when we get there. Now, verification wise, it's going to be pretty much the same commands like in any kind of regular verification. So we say show policy firewall config class map, but if we say only show policy firewall config class map, we are going to verify the regular layer 2 layer 4 class maps. If we say show policy firewall config class map HTTP, that means show me the layer 7 class maps which are inspecting HTTP traffic. That's the new command. The old command is going to be show class map of type inspect and the protocol. We verify the application policy maps like I use the same command, show policy firewall config policy map HTTP or FTP or SMTP. So show me the policy firewall configuration and show me the policy maps which are where I'm inspecting HTTP or FTP or whatever is the protocol you want to inspect. Or the old command, show policy map type inspect and the protocol. Further on, the verification is going to be like any other zone-based policy firewall verification. We say show policy firewall config zone pairs to see where have we attached the application layer inspection, or show zone pair security. And then as traffic flows through the firewall to verify the active sessions in a state table, show policy firewall session zone pair or show policy map type inspect zone pair sessions. So now going to our setup in here, what we're going to do is the following. As traffic flows inside, outside, in there, which was LAN to internet, I'm going to perform HTTP inspection for that traffic. So DPI for HTTP traffic, which can be, of course, a lot of ways to inspect HTTP. What I'm going to be doing is the following, to be able to also show you the outcome, the result, because it doesn't make sense for me to inspect Yahoo Messenger or whatever else, because I don't have access to the internet from the rack, so I cannot show that it works or it doesn't work. So what I'm going to be doing is I'm going to perform DPI for HTTP, and from PCA I'm going to access two websites. Let's say CISCO.com, which is going to be allowed, and test.com, which is going to be dropped. So I want the router to perform like DPI for HTTP, application inspection for HTTP traffic, in order to drop traffic if traffic goes to that URL. I want to drop users traffic if they go to that URL because of whatever reason. It's malware. So before we go to the actual configuration, let's make sure that PCA has a DNS server of router 1. And on router 1, I'm going to go and map both of those domains, cisco.com and test.com, to the loopback 0 of router 3. So in the end, actually, the PC is going to send traffic, when it's going to access those two URLs, traffic to router 3's loopback address. And if traffic is going to go to cisco.com, it should be allowed. If traffic goes to test.com, it should be dropped. So let's first verify the DNS configuration. Let's build it. Let me go on router 1, which is the DHCP server for PCA. Show run section IP DHCP. And DNS server is 172.16.10.100. Let's go on PCA and see if PCA can access. Actually, let's go on PCA to make things faster. Let's go on PCA and put the DNS server to be router 1 to be faster in this process. Change adapter settings, lab connection properties, and put the DNS server to be 10.10.11.1. So 10, 10, 11, 1. Now let's go on router 1. Make it a DNS server. Put those host names to begin with IP host. Name of the host www.cisco.com. Maps to 5553. If I don't specify the type, it's going to be a record, which that's what I need in DNS to resolve the host name IP host www.test.com. Maps likewise to the loopback router 3. And then IP DNS server. Enter. Now let's go on the PC and say NS lookup. And let's try and resolve Cisco.com. It resolved properly to 5553. And test.com. It resolved properly to 5553 likewise. Okay. Now let's go and configure our policy in there to drop traffic to test.com. So let's try, and I'm going to build a parameter map, although it's not required in this case, just to show you. Parameter map type regex. Let's name it URL filtering. And we say pattern, specify the regex pattern. So I want to drop traffic destined to test.com or to www.test.com, actually, that specific website. So I'm going to say traffic destined to w.w. So I'm putting in there, I'm building the regex like this because I don't want the user to try and bypass my policy by putting capitals or smalls and as it types its URL in the browser. W and the dot matches on everything. So www w. Then because I want to match on the dot, otherwise the dot means everything, I put that backspace and then I say test dot com. So this is going to match on W capital, W small, W capital dot T capital is small, S capital, T capital, that C, O small, M small. That's what I build the regex like this. I don't want the user to try to obfuscate, bypass my policy by writing its URL like this. So it's my configuration, I'm going to match on www.test.com regardless of how the user types it in its browser. And then here I'm putting backslash dot to tell the router that to tell the router to match exactly on the dot in there, because otherwise if I don't put backslash dot, the dot means everything. So if I would build the policy without the backslash in there, it means that this is going to match on W in whatever format, small or capital, W, W, and then before T, instead of the dot in here, instead of the dot, as if it's configured like that, can be anything. Can be an A, an B, an X, whatever. So I don't want that. So the backspace tells the router that what follows after the backspace, it's not a special character, because dot is being used in regex to match on anything. This expression tells the router that I want you to match on the dot, so interpret the dot as a dot, not as anything. So I build the parameter map pattern, and let me make sure I don't have a space in here, and I don't. Then we build a class map of type inspect. Class map of type inspect. exit. Class map of type inspect, but of type HTTP. And likewise, depending on how many conditions you put in the class map, you may want to be a match all or a match any. Let's say match all. Give it a name. I'm going to call it CMAP HTTP inspect. HTTP DPI, let's say. CMAP, let's say DPI HTTP. And here I'm saying match. And because I want to match, I want to use the regex, we know that the user is going to send a HTTP request to those websites. HTTP request. He's going to request, that's the method, content from cisco.com or test.com. So I want to match on the request. And in the request one, what do I want to match? Of the method, on the method which can be like connect, which is like a tunneling, or it can be the regular get methods. So this is something which is specific to actually application layer. But for sure, I'm matching, I want to match on the request, but not on the method of the request. I can match either on the URI or I could match on the header. Both of them are going to match on the URL, but URI is going to be matching on partial URL, header, host, and regex. This is going to match exactly on the full URL. Actually, host, it should be URL filtering. So do show run class map. There we go. So it's a match all. What else can you say? Match, for example, request, port misuse. Like if it tries to do any kind of tunneling, port misuse any. So this means do show run class map. This means that my configuration, my advanced class map inspection states that on the HTTP traffic, I'm going to match on the www.test.com. And also, so for this class map to match on the traffic, then the URL has to be test.com, and there has to be a port misuse of any type. Which port misuse means that the user tries to tunnel something over HTTP. Which means that let's change this to match any in order to make this policy actually match in the end, because I'm not going to be able to tunnel something over HTTP. So I'm going to change this to match any, which means that if traffic is destined to test.com, or if the user tries to misuse HTTP to do some tunneling, then I'm going to match on the traffic. And then let's put the action. What is the action? Policy map, type inspect. Let's say pmap, DPI, HTTP. And we say class, that class map. Of course, policy map type inspect HTTP, not a regular class map. So I said something and type something else. So policy map type inspect HTTP, that, and calling the application class map, class. I copy pasted something wrongly, so let's put the policy map. And let's call in the class map, which was named CMAP DPI HTTP. And what do I want to do is I said reset. Reset and let's say log. So I'm going to drop it and log. Reset and log. So do show run policy map. So reset and log. Okay, let's put this in Notepad in here and do show run class map, which is this one, and do show run section parameter map. Let's put also my regex in there, and here we go.